So today's webinar is on initiating file transfers from the touchscreen of the OCS. It's roughly a 20-minute presentation, and as usual, if you have any questions, you can put them in at any point and we'll get to them at the end.
Hello and welcome to today's webinar. Today we will look at how to initiate file transfers from the OCS touchscreen. Let's look at our agenda for today. We will start by discussing which OCS models allow you to do local file transfers between microSD and USB. We will then look at some of the applications where this is useful and the different types of files you might be transferring. Finally, we will look at some of the key functions in Cscape and in the OCS for performing local file transfers. There will be demonstrations throughout, and we will finish with a Q&A session. First, let's look at which OCS models support the ability to transfer between microSD and USB flash drives. Every OCS has a microSD slot. Any OCS that supports both microSD and USB Type-A can support file transfers. This includes the X5 and X5 Prime, the XL series from the XL4 up, the XL Prime series, and the upcoming Canvas series. These criteria also mean that the micro OCS models X2, X4, X7, and X10, the XLE and XLT with or without Ethernet, and most RCC models don't support file transfers. Next, let's look at some useful applications for local file transfers. If you don't have Ethernet available, or you don't have a local plant network that your machine is mounted on or communicating with, then using local file transfers can be a convenient option. From a maintenance standpoint, local file transfers can also be useful if you want to copy a program file from USB to microSD prior to loading it onto your machine. Local file transfers can also be helpful when dealing with production type data or quality control type data. For example, if you have a daily or weekly report that's automatically generated by an OCS, and you want to transfer it from microSD over to USB without opening up the control enclosure. They can also be helpful for datalog files for quality control if you want to transfer files from microSD to USB. If you want to transfer files between microSD and USB, then a USB extension cable like the one shown that can extend access to the USB port to outside the control enclosure can be very useful. Many of these cables also maintain the IP or the NEMA rating of the enclosure. With these cables, you don't need to open up the control enclosure. Instead, you unscrew the cap over the USB port, plug in the drive, and then from the touchscreen, you can perform the functions that we will show in today's demonstrations. There are a lot of functions and features in the OCS that support removable media, such as data logging and report generation. There are also functions that can be accessed from the System menu that can be used for loading programs and cloning. All of these functions either use the System menu or their own custom dialog box to configure. However, to use the Copy Removable Media file highlighted, you need to use one of the removable media function blocks available in the instruction set in Cscape, which we will look at today. The copy function block available in Cscape doesn't have many inputs and outputs. The only input is the source, which is typically the file name or series of file names that you will be copying. The destination is the location where you want to put these files. There is also a status register or status variable you can assign that tells you if you were successful in copying your files. When you fill out the source and destination fields in this function block, you can either enter the data directly between single quotes, so the exact file name and path on the source side and the exact path on the destination side, or you can use variables instead. If you use variables for the source or destination or both, then for variable-based advanced ladder, these will be byte array type variables, and for register-based ladder, these will be registered references, which can contain up to 2 characters per 16-bit register. So if you had a string of 10 consecutive registers, that would give you the ability to handle a string with up to 20 characters long. Let's look at an example of copying a program or PGM file from the USB drive over to the microSD card. You can load programs straight from the USB drive. However, it's a good idea to have a copy of the microSD card inside the main microSD drive of the controller, which you can load your programs from. We have typed in directly the paths for the source and the destination, all between single quotes. The B: in the source path indicates that our source file is in the USB drive root directory. This is followed by a slash, and then the name of the file we want to copy. This file will be copied to A: between single quotes, which represents the microSD drive. If we leave out the drive letter from the destination, then it will default to microSD. We also have assigned a status variable here called program copy status, which is just a 16-bit integer. Similarly, you might want to specify variables for your source or your destination. In this scenario, if you're using variable-based advanced ladder, then you will be using byte arrays for both the source and the destination for this. When using these copy function blocks, whether it's with variables or path destinations between single quotes, you can use DOS wildcards, such as the asterisk and question mark, within the file names and paths. For example, asterisk.asterisk would specify a whole group of files that you might want to copy. Or a series of question marks, followed by a .csv for instance, could be used to indicate a file name of a certain length with .csv as its type. Now let's look at the status variable of the copy block in more detail. If your file transfer is not successful, then this variable will tell you specifically where it went wrong. For example, if we look at the list on the right, we can see that if you returned a value of -4, it means the function block has not been enabled. If you get a value of 0 for your status register, then the file transfer was successful. If you get a value of -2 or -3, this means the function is active and waiting on another function to complete. All other values are errors. Another function that is useful in this scenario is the removable media manager graphical object. This isn't required to copy files from USB to microSD or from microSD to USB, but can be a useful tool. The removable media manager object allows the user to see at a glance based on the color that both the microSD card and the USB drive are installed. In this case, if they are successfully installed and not full, the buttons will be green. If the USB drive was removed, or for some reason it wasn't recognized when it was plugged in, then the USB removable media manager object we have configured here in our example won't be green. If you want to take a look at the details of the files that are contained in the individual drives, then this object also allows you to do that. By pressing the button highlighted, for example, the user can see a listing of the files and directories in the USB drive. This object also allows you to delete files, change directories, and load programs. Now we will look at how to transfer a PGM file from USB to microSD. First, we will go into Cscape and look at the screen that we have developed for our program in the graphics editor. Here we have a push button that the operator is going to press to initiate the file transfer from USB to microSD. If this file transfer is successful, then the screen success light will turn on. If it is unsuccessful, then the red fail light will turn on. The user will also be able to briefly view the status of the file transfer here. If the user wants to look at the individual files within the USB or the microSD, then they can do so using these objects in the bottom right corner. We will double-click on the USB object, for example, to look at the object properties. Here we've configured the B drive as the starting directory, which is how we specified the USB drive. Then to specify the microSD, we can either specify A: or just leave this blank. Next, let's look at how we have set up our function in our ladder logic. When we push our push button here, this will turn on a set bit, which will keep the copy block active as long as it needs to be to execute the function. So it's better to not use one-shots here to enable a copy removable media function block, as we want it to execute to completion. The source on our function block here is a specific file name, and the destination is just the A drive because we're copying the specific file from USB to A. We also have our status variable here. Then we have some logic to see if our file transfer succeeded or not. So while we are copying the file, if we get a 0 for our status, this means we are successful. So we set the OK bit and we clear our execute bit. If we don't get a 0, and we also don't get a -2 or a -3, this means we have an error. So we set the error flag and turn off the execute button. We also have a clear push button that we can press to clear the status of everything so we can do another transfer if we need to. Now let's look at our bench setup for this demonstration. Here we have our program set up on our OCS. We can see that we currently have a status of -4, which indicates that the function block is not enabled. In this example, we want to copy the file default.pgm from USB to microSD. So we will first check our USB object and make sure that the file is in there, which it is. We can also check our microSD object, and we can see our file is not in this drive yet. We will execute our file copy by pressing our button. Our green success button has lit up. Now when we check our microSD directory, we can see our file is now there. Now we will try to copy the same default.pgm file to the microSD directory again. First, we need to clear the previous operation so we can do another one. When we execute our program again, we can see we have gotten a success again. So a previous copy of the file will be overwritten if it already exists in the destination. In the next demonstration, we will be moving some datalog files from microSD over to USB. First, let's quickly review datalog files. Datalog files are stored on a folder in the microSD that's equivalent to the name of the datalog group. So if you create a datalog group called process data, for example, then those datalog files that are created will all be within a folder called process data. The files are automatically named depending on how the datalog has been set up. So if you set up a datalog to record variables on a periodic basis, for example every 10 seconds, then the files will be automatically named after the month, date, and hour in which it was created. And at the start of every hour, a new file will be created with that file name and will change based on the real-time clock. If you instead have a datalog file where the variables are logged in terms of minutes, or where variables are only logged when triggered by a bit turning on, then the file name is in a year, month, day format, and you only get one new file per day. If we want to copy datalog files selectively, then it is important to understand how the datalog file names are built, so that we can properly fill out the source path in our function block and find the files we want to copy over to USB. Now let's return to Cscape. For this demonstration, we want to look at a different section of our program, and we will first look at our screen setup in the graphics editor. Our screen setup is very similar to our previous example in terms of the controls that are on the screen. However, this time the user will select the month, date, and year for the datalog files that they want to copy, and then press the Start Copy button. Next to this, we have a button which will turn on if the copy is successful. In this scenario, we are copying two sets of files as there are two different datalogs running in our program. So if we have a problem copying either or both files, these buttons on the right will turn on. We can also see the source paths and destinations of the files we are copying, so that we can see what we will be building based on the time and date that has been specified to be copied. Next, we will look at our datalog configuration. To do this, we will go to Program, then Datalog Config. Here we have two different datalog groups. The first group is being logged every second, so our file name is based on the month, date, and hour. Our other datalog is trigger only, so it's only going to be logging the variables whenever it's triggered, and we will just have one new file per day. So the names of the groups are going to effectively correlate to the folder in which the files are contained, and the names of the folders are going to be built based on the real-time clock. Now let's look at our logic. Most of the logic in this example is about building the file names that need to be copied. This is important as we are selecting datalog files to copy by the date they are from. We start by building the source, file name, and path here. We have the source path, which starts with the directory that the files will be contained in. We then have fill-in characters here for where the month, date, and hour will be filled in later in the logic. Then we have the destination for the files, in the case of the first datalog group. Here we are just specifying a folder name called test data. Similarly, we're building the first part of the path and file name for the trigger type datalog, and then the destination for the trigger type datalog. Now we have built the first part of the source and destination. Once the copy button is pressed, we will then need to fill in the rest of the details of the source file name based on the month and date for the files that are created hourly, and based on the year, month, and date for the datalog files that are created daily. So based on the real-time clock, the date is filled in there, and we move the characters over to the right location. In the case of the files that are created every hour, where we would be copying multiple files, we will put an asterisk.csv at the end, so that we get the files that meet the criteria that we've set up in our file name. So now we have finished building the file names for sources and destinations, and we will perform the copies in sequence. We will copy the hourly data first, and once that is successful, we will copy the daily data, and then we are finished. Now let's look at our bench setup for this demonstration. We have set the target date for the files to be copied as the 23rd of April 2024. In the lower right corner, we have the source paths and destinations for both sets of files we want to copy. We can see in the first source path that we will be copying every file in the test data folder whose name starts with 0423 and ends with .csv. In the second source path, we're specifying the entire file name, which is 240423.csv, which is in the same test data folder. First, we will clear the previous test we did, and then we will select our object and see what we currently have in our microSD drive. We can see that our test data and trick data folders are there, with data inside them that can be copied. Now if we look at the USB drive, we can see that these folders are not there, so they have not been copied yet. Now we will execute our function by pressing the Start Copy button. Now let's check our USB drive again. We can see our test data and trick data folders have been successfully copied to the USB drive. If we look at the test data folder, we can see that 7 files have been added. This is because of the copy instruction we had in our source path for the test data folder. For our trick data, we can see that just 1 file has been copied into the USB drive, as we gave the specific file name for the source path. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.
Okay, if any of you would like that program just to test it or anything, you can contact us at tech support and we can get you a copy of that. I'm not seeing any questions on that. So I'll just give another minute or two. As usual, the upcoming webinars will be found on the website under the support section, so you can just go for registration there for any upcoming topics that you would like to see. And if there's any topics that we haven't covered and you would like us to cover, just let us know as well. Okay, I think that's everything. Thank you all for coming this morning, and we'll see you next time.